There is something exciting happening in Venice this week, and I am not talking about a certain high-profile wedding. This week, along with the bustling tourists, hundreds of physicists will be descending upon this ancient city in order to talk about the future of our field. We have the open symposium for the European strategy of particle physics that will be taking place all this week. Let's find out more. If this is your first time seeing me, hi, my name is Clara and I am a particle physicist working on the ATLAS experiment at CERN. I'm also an assistant professor at the University of Amsterdam and at NICEF. And I love to talk to you here about particle physics, both current results, historical information, and basically answering any questions that you might have about particle physics and CERN. If you're not subscribed already, please do subscribe to my channel and then you'll get all of the notifications when a new video comes out. Now, let's learn more about the Open Symposium. First, let's talk about the Large Hadron Collider. This is the collider that we have at CERN currently, and it collides protons and sometimes heavy ions in the center of detectors in order to recreate conditions of the early universe, to study particles that we've already discovered in the Standard Model, and to search for new ones as well. In the next few years, we are going to be upgrading the Large Hadron Collider to something that we call the High Luminosity LHC. And this upgrade is going to be almost like having a brand new collider. There are going to be so many improvements to the accelerator and also to some of the detectors that we are going to be able to collect an incredibly high amount of data with this version of the LHC. And this means we're going to have a really useful data set to study for the next 20 years and beyond. But building a new collider and planning for the future takes not only years, but decades. And so we need to think about what's next as well. If the Large Hadron Collider is so great, and it is, why do we need a future collider? And what are some of the limitations of current colliders that we need to overcome in these future versions? Well, in the tunnel before the Large Hadron Collider, we had an accelerator called LEP, the Large Electron Positron Collider. And this collided leptons, electrons and positrons. Now, one of the limitations of this collider is because those particles were so light, they lost a lot of energy called synchrotron radiation as we changed their path around the curved accelerator. And this was a major problem because the energy that we could reach with this collider was limited by this loss due to the synchrotron radiation. So we then replaced that accelerator with the Large Hadron Collider and accelerated protons, which are more massive. One of the downsides of using protons is that they are not fundamental particles like leptons are. They have quarks and gluons inside of them. So we're never sure exactly what the energy of the collision is because only a fraction of the energy that we give these protons is actually provided in the collision. But because they're more massive than electrons and positrons, they lose less of their energy from this synchrotron radiation. Now, one of the limiting factors we have for the Large Hadron Collider is the magnet strength. For the fixed ring, we want to keep the protons going around in the circle. So as we increase the energy, we need the magnets to be even stronger and stronger. And at some point, we just reach the limit of the current technology. So some of the ways to overcome these limitations are, one, we could just increase the size of the ring that we use for our accelerator. With a bigger ring, we have less of a curvature for those charged particles going around, and so we can reach higher energies with leptons and lose less synchrotron radiation as they pass around. It also means that for this larger tunnel, we can use the same magnets that we currently have, and we can get to higher energies with hadrons. And as magnet technology improves, we can reach even higher energies with hadrons in this larger tunnel. The other option is just to have the particles go in a straight line. And if you don't have a curvature at all, you don't have to worry about synchrotron radiation limiting the energy of your particles. You're then mostly limited by the accelerating gradient of your accelerator and the length of your accelerator. Another option would be to change the type of particle that you're colliding. So a muon, for example, is a lepton like an electron, so it's a fundamental particle and doesn't have smaller particles inside of it, as far as we know, but it is more massive than an electron. So you could use a muon to do your accelerating and you're less limited by synchrotron radiation, but you still get the benefit of it being a fundamental particle. These are just some of the options that we are going to be discussing this week at the Open Symposium. symposium. And let's not forget about potential additional upgrades to the HLLHC that could be a bridge between what we have now and a future collider. And this is all on the table this week to discuss, because we want to make the most of the opportunity that we have in order to fully study our universe on the smallest scales with the best technology we can possibly build. What's interesting to me about some of the projects that we're discussing is that the time scale for constructing these future colliders, for many of the people who are having this discussion now, they will be retired by the time the colliders even start. And we do have early career folks involved in the discussions, but even for them, they may be at the end of their careers when some of these future colliders really get going, and they won't be around probably for the end of the data taking. So I've grown up on a lot of sci-fi. I really love science fiction programs, and I read about, starships that are multi-generational projects. And for me, this is one of those multi-generational projects that we are planning the future of particle physics for the next generation of physicists. And I liken it to the proverb of planting the seed of a tree, and that you may never get to experience sitting under the shade of that tree, but you plant it for the next generation. And in the same way that I have got to enjoy the shade of trees that were planted before by previous generations of scientists, standing on the shoulders of giants, I get to be part of the process that plants the trees, that builds the colliders for the next generation of physicists. And I think that's really, I find that really important to me about the process that we're going through right now. The European Strategy for Particle Physics takes place every 7 years or so, and it allows us to review past achievements and to set priorities for the future. This year, there are over 250 different contributions from nations and collaborations. And we're not only focusing on the science, we're also talking about sustainability and diversity and inclusion, science communication, and a range of other topics. It's going to be a very exciting meeting.